Hello my dear students, welcome to your Geography's online class. Today we will be discussing a new chapter, that is insolation. In this chapter we will try to understand what insolation means and how it affects the temperature of a region, and then the factors affecting the temperature of any region on this earth surface. So first of all, let's try to learn what insolation is all about. So insolation, what it means? We say insolation is an incoming rays of the sun that heats the earth and its atmosphere. So the incoming rays of the sun that we are discussing about is the heat or the light energy that is emitted out of the sun. The sun, on giving its heat out of it, these rays of the sun passes over the solar system, and earth, being a part of the solar system, happens to receive the amount of heat radiated by the sun. So this heat energy that the earth receives, and in turn later its atmosphere and the land surface gets heated, to that is what we call insolation. Now this insolation, for example, you see this is the land and we have the sun. The rays of the sun that reaches the earth's surface, and in between, before it reaches the earth's surface, it happens to pass by the earth's atmosphere. So this atmosphere absorbs some amount of heat. At the same time, the heat also reaches the earth's surface, and this incoming rays is known as insolation received by the earth. Now this insolation, since it's heating the earth's surface, later on heating the earth's surface, what happens is land, that is earth, on the earth being heated, it starts radiating some amount of heat back to the space or back to its atmosphere. So this heat that radiates back to the atmosphere, or you say back to the space, is known as terrestrial radiation. So one, we see the earth on its receiving end, while on the other side we see the earth giving out its heat energy. So here the amount of heat that the earth receives as in form of insolation is known as short wave radiation. And after the earth being heated, the energy that it releases is known as long wave radiation. Or this very long wave radiation is also known as terrestrial radiation, as here terrestrial refers to the surface of the earth. So this is about the insolation that we discuss about. This helps in increasing the temperature of the earth's surface and thereby also releasing the heat. Now we will be discussing about the factors that affects the temperature of a place, a particular place. Now when we talk about temperature of a place, we see that no place on the earth has the same temperature condition, or you may find variations in the temperature from one place to another. So to that is what we call the factors that governs or that affects the temperature of that particular place. So let's discuss them one by one, that what are the factors that affects the temperature. So the first factor is latitude. The latitude that we see on this earth surface, or in fact on the map, is been distributed from 0 to 90 degree north and south. So you'll find latitudes numbered from 0 degree to 90 degree north and south. So here in this case, what happens is, if we see the globe, you will find that the rays of the sun received on the earth's surface is not the same, as because the earth's latitudinal lines, we see 23.5 degree north and south. Only between these latitudinal lines the sun's movement is experienced. The sun either north until 23.5 degree north and to the south until 23.5 degree south. So these are the only region that receives almost the vertical rays of the sun throughout the year. While when it happens, this is the vertical as well, it happens to the 90 degrees and some 80s and 60 degrees or above 23.5 degree, in most cases we find they only receive the slanted rays of the sun. And slanted rays of the sun are less effective in raising the temperature of the earth than that of the vertical rays. Hence, we find in terms of latitude that the lower latitudes are much more warmer than as compared to the higher latitudes, as because the lower latitudes that receives almost the vertical rays of the sun throughout the year, while that in the higher latitudes they mostly receive the slanted rays of the sun. So this is how the latitude affects the temperature of a place. Now let's discuss about the second factor, that is altitude. So altitude means height of a place. Now the height varies from region to region or from one place to another. So in this case what we find is, owing to the concept of lapse rate that is within the tropospheric layer, the troposphere extends up till 18 kilometers over the equatorial areas and some 10 to 12 kilometers over the poles. Now in tropospheric layer, what is the unique character is that we find is that as we go higher of the troposphere, the temperature tends to decrease, and to that is what we call lapse rate. Lapse rate, decrease in temperature with increasing height at 6.4 degrees centigrade for every 1000 meters that we climb high. So this is where the temperature happens to decrease, and in case of altitude we find the same, that when we increase in height with the land masses, here we see the temperature in this point, that is, let's consider this to be point B and here this point A. The temperature in point B will be less than as compared to point A because of lapse rate, as point B is higher in height than as compared to point A. So if you consider 20 degrees centigrade at point A and then consider point B is above 2000 meters of point A, then here the temperature, as we see 6.4 degrees centigrade per 1000 meters, it's decreasing. So here the temperature will be minus 12.8 degree centigrade. That means 12.8 degree centigrade less than that of 20 degree. So when we calculate this, 20 degree minus 12.8, it will be 7.2. So the temperature at point B will be 7.2 degree centigrade. And now the temperature recording itself shows that it's quite cold. 7 degrees is very cold, while 20 degree is a mild condition. So this is how we find that the temperature from one place to another because of height varies. Now to make note, we need to understand that it's not just one factor that affects the temperature of a place. Various factors plays a role. For example, if you consider latitude and altitude, equatorial area 0 degree, it's a lower latitude where we say that the temperature is high there because they receive vertical rays of the sun almost throughout the year. But even in the equatorial areas there are some lands which are higher in height, and in such lands despite being located in the equatorial areas, because of the height factor or altitudinal factor, temperature there decreases. For example, Mount Kilimanjaro, which is located very close to equator, we are supposed to be experiencing high temperatures as for latitudinal factor, but Mount Kilimanjaro has higher elevation, so because of height, despite located in lower latitudes, there the temperature is less. Now let's discuss the third factor that affects the temperature of the place. So the third factor is distance from sea, or you can consider as water bodies. Here we see it's written as places far away from water bodies experiences extremes of climate than the place located close to the water or water bodies. So what it means is, water, because of its differential heating as compared to land, here I mean to say that water heats and cools much slower than the land masses. So in this case, what happens is, the cool effect and the warm effect of the water comes towards the land masses. So hence, the places that are located very close to the water bodies, they experience a very moderate condition or moderate climate. That means temperature is not very high or not very low. While of those places that are located far away from the water bodies, they happen to experience extremes of climate. That means temperatures, either it's very high or it's very low. This all happens because of differential in heating of land and water. Mumbai, if you take an example, and another city is Delhi, if you take it, then you see Delhi is very cold during the winter season, while during summer season it's very hot. But Mumbai, since it's located very close to water bodies, it's not very hot, neither very cold. So this is an effect of the water body. So the fourth factor, winds and ocean currents, they tend to either increase or decrease the temperature of a place. It depends on what kind of winds and ocean currents blows in that particular region. So if the ocean currents or winds, they are cool or cold in nature, then it happens to decrease the temperature of a place, while that of the warm ocean currents and winds, they tend to increase the temperature of a place. The place, in fact, you can say that they affect the temperature of a place by either increasing or decreasing the temperature. Warm winds and ocean current increases, while cool or cold winds and ocean currents decreases the temperature of a place. The fifth factor is slope of land. In this context, we try to understand with the help of the mountain barriers that how do they affect the temperature of a place. Like if we see the Himalayas in this case, then you would find that it happens to obstruct the rain-bearing winds during the summer season and the cold winds blowing from the north during the winter season. And in both the cases, it happens to regulate the temperature. How? If we talk about it, then we see that the Himalayas, if we see this as a rain-bearing wind, so I write it as moist wind, and then coming from the north is cold winds. During summer season, the moist wind that blows from the water bodies is obstructed by the mountain barriers. Now on its obstruction, this moist wind sheds its rainfall, shed its moisture here in this place where rainfall is occurred, and hence decreases the temperature during the summer season. While during the winter season, the cold winds that blows from the north is obstructed by the mountain barriers, and thus this cold wind cannot enter or cannot come towards this side of the mountain, and hence there is no such extreme condition of coldness been affected in this particular region. So this is how mountain barriers acts as the climatic divide. Now in case 2, what we find is also that the slope of the land plays a very important role in determining the temperature. How? If we see, the mountains, they have a side of it facing the sun, while the other side it does not receive the rays of the sun. Again, let's take an example of the Himalayas. Consider this to be the south facing slope and this as the north facing slope. Now the north facing slope of the Himalayas is above 23.5 degree north, that is Tropic of Cancer. So hence the rays of the sun reaches only the south facing part of the Himalayas or the south facing slope of the Himalayas. So in this case what happens is, in the south facing slope of the Himalayas, the temperature tends to increase or is slightly higher than as compared to the north facing slope of the Himalayas. So this is also there when it affects the temperature condition of a place. Now you see, onto the northern part of these Himalayas, that is north facing slope of the Himalayas, here the temperature will be less, hence it will be very cold, while that in the south facing slope, since the temperature is slightly higher because it's facing towards the sun, hence the temperature would be slightly higher. There are also other indications, like during the winter season mostly it happens, the high altitudinal areas tends to experience a warmer condition as we go higher the height. This is known as inversion of temperature. Inversion of temperature means temperature increases with decreasing height. This so happens because the lower level of the atmosphere now becomes more cooler than as compared to higher level of atmosphere. So this results in inversion of temperature and hence is what we call inversion of temperature. So this is it for the day. Thank you very much class, and you all have a very good time.